Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us find the input impedance of transmission line for various load conditions. So we have found the generalized expression for finding the input impedance of a transmission line in the previous session. Now we are going to apply the special cases such as when the line to a load having a zero impedance, that is it's a short condition. When it is when the line is terminated by short circuited what happens, the input load ZL is zero. Substituting here in this impedance formula, we get Z0 cancelled, and J Z0 and beta L is the input impedance for short circuited line. So we apply the same ZL is zero in the reflection coefficient formula, and we get minus Z0 by Z0, that turns out to be -1. And for finding the VSWR, corresponding VSWR for this reflection coefficient -1, we put 1 plus magnitude of that, that is 1, divided by 1 minus magnitude. So we get 2 by 0, that is infinity. So the final conclusion is input impedance of a short circuited line is J Z0 tan beta L, and the reflection coefficient for the corresponding load is -1, and its VSWR is infinity. And this graph shows that for a short circuited line, for a various length of the line, that is beta L, right? When beta L is varied from pi by 2 to 2 pi, how the input impedance is getting varied. So until pi by 2, it is an inductive impedance, and after that it is going to capacitive, then again inductive. Okay, so we can see a short circuited line behave as a inductance at some length. After that it acts as a capacitive load. Okay, now let us find the input impedance of a line for open circuited condition, that is when the load is connected with infinite impedance. So in that case, we can't directly apply ZL as infinity, which makes the entire expression to be infinity. So we take ZL common, and if I take that, we get 1 plus J Z0 by ZL into tan beta L. Similarly down, Z0 by ZL plus J tan beta L. So after taking ZL common and cancelling it, 1 by ZL is nothing but 1 by infinity. So if we substitute 1 by infinity as 0, we get Z0 into these terms will become 0. We get J tan beta L denominator. So if we make tan beta L, 1 by tan beta L is cot beta L, and 1 by J is minus J. So the open circuited line will be having the impedance of minus J Z0 cot beta L. And if we substitute the same ZL, we can't substitute directly infinity, so take ZL out from the generalized expression for the reflection coefficient here. After taking, we get Z0 by ZL. So here if we apply ZL is infinity, 1 by infinity 0, and we get 1 by 1, that is 1. So the reflection coefficient is 1, and the corresponding VSWR turns out to be same, infinity only. For open and short circuit case, the VSWR is infinity. Reflection coefficient, there it is -1 for short circuited load, and here it is +1, right? And one more interesting fact, that if we multiply the circuit input impedance with the short circuit input impedance, you can see here minus J square will become 1. Okay, cot and tan will get cancelled since both are reciprocal each other, and Z0 square we will get. So ZSC into ZOC is equal to characteristic impedance square. Now let us find for the matched condition. For a matched line, ZL equal to Z0, if we substitute that condition, we get the reflection as 0. Okay, and if we substitute for VSWR, we get 1 plus 0 divided by 1 minus 0, that is going to be 1. So reflection coefficient is 0 and VSWR is 1. What is the meaning? That means there is no reflection. reflected voltage wave is 0, whole wave is transmitted, incident wave is transmitted, and that power is fully absorbed by the load. And we can say that maximum power transfer will be occurring when the transmission line is matched to the load. Characteristic impedance of the transmission line Z0 is equal to the load impedance. In that case, we get the maximum power transfer possible. So in this session, we have discussed about 3 load condition, and we found the input impedance, corresponding reflection coefficient, and VSWR for open circuited load, that is 0 impedance, and that is short circuited load 0 impedance, open circuited load, that is infinite impedance. Finally, matched condition, that is AZL equal to characteristic impedance of the line. And this is the perfect thing, that is practically we need only this condition, matched condition only, for the maximum power transfer to take place. Hope you understood. Thank you everyone. Happy learning. We will meet next time.